This is number 4 on your More Modeling worksheet. It says the population of Champaign, Illinois is given for 3 years in the table below, and your table looks just like that. For part A, it says using 1970 as t equals 0, create a linear model from the first 2 years in the table to predict the population. So this is why applications are so important, because we can use math not only to describe what's going on, but also to predict what our values are going to be. So if we're going to write an equation, the first thing we need to do are define some variables. So it tells us t equals 0 is 1970. That's nice because then we don't have to work with a big number like 1970. We can just say, okay, that's going to be, if we're going to make a little middle column here, we're going to make this t equals 0. And if 1970 is t equals 0, 1980 would be t equals 10, because that's 10 years later. Those are really the only two values we need if we're going to write an equation. Because the first thing we want to do, always, if we're going to write an equation, is find slope. Slope is going to be our rate of population increase in this situation. That's what slope is going to represent. So our 2 points are going to be 0, 163,488. So here's our first point. And our second point that we'll use is 10, 168, 392. So we'll do 0 as x1, 163, 488 as y1, 10 is our x2, and 168, 392 is our y2. So the first thing we're going to do is find slope. So y2 minus y1 over x2 minus x1. You don't have to worry that you have such big numbers. You guys all have calculators, so put it in your calculator. You get 4,904 over 10, and that reduces to 490.4. So that's our slope. That's our rate of population increase. And now we want to write an equation. So I'm going to go ahead and add a page here. So for part B, we're writing an equation. And remember, we're plugging into y equals mx plus b. And you could use point slope like we did on the last problem, or if you remember from our notes, m is our rate, and we already found that. B is your starting amount. And if you look back at your table, we have our starting amount. When our time is 0, our population is 163,488. So our starting amount for this problem comes from that first line of our table. And we just found our slope. So let's go ahead and plug it in. Our slope was 490.4. And our starting population, and that's perfect. If you wanted to use like t as for time and p for population, it would look like this, using function notation. I'm sorry, that was part A still. So there's your equation, either of those two equations. Perfect. Now for part B, it says if this model is used to predict the population in 2012, will the model overestimate or underestimate? So I'm going to actually flash back to to our table. We need to figure out what our t would be here. So if we do 2012 minus 1970, that gives our t as 42. So what we want to do is use the equation we just found, plug in 42, and see if we get 203,276. So we want to see if we get this situation to match. or if our model, our equation that we just wrote, overestimates or underestimates, gives us too big of a number or too smaller of a number. Okay, so let's make a new page here. So we had our time is 42, and we want to see what our output is of our equation. So we had population at time 42 equals, our slope was 490.4 times our time plus our initial population, 163,488. And then all you have to do is put this in your calculator, and you get 184,084.8. So if you look back at your table predicted, or the actual population was 203,276. This number is smaller. So our model wasn't great because in 2012 our numbers didn't match. And that's okay. Your models are never going to be perfect. Our model actually underestimated the population. Since our number that we got from our equation was smaller than the actual population. That's number 4.